Hello, in this video we're going to talk through 3 titration problems. These are from page 22 in your OneNote if you want to follow along there. And these reactions, these titration calculations all involve acid-base neutralization reactions. So first step is to find your balanced chemical equation. So in this case the problem is giving us the balanced chemical equation. Sometimes we might need to write that out. So you want to predict the products and then use coefficients to balance that equation. Okay, so if we look at what we're given here is we have a 75 ml sample of sulfuric acid and we don't know the molarity of it. So we got unknown molarity. What we do know is that it takes 50 milliliters of 0.3 molar sodium hydroxide, that's my base, to neutralize this sample. So we're going to use this information that we collected in a lab to determine the concentration of the sulfuric acid in my original container. So first step is to find the moles of base that I added. So since molarity is moles per liter, we can rearrange that and say molarity times liters equals moles. So my molarity of my sodium hydroxide is 0.3, and then my liters is 0.05. You got to make sure you take your milliliters and divide it by 1,000 to give you liters. Always remember that step. And if you plug this in your calculator, 0.3 times 0.05, you end up with 0.015 moles of NaOH. It's always good to label what it is so that you don't lose track of whether you're talking about acid or base. Okay, so now that I know moles of sodium hydroxide, I need to find out moles of sulfuric acid. So this is a stoichiometry step. Whenever you're going from moles of one thing to moles of something else, you're doing some stoichiometry. You're going to be using the mole ratios from the balanced chemical equation. So I'm starting with what I know. I know it took 0.015 moles of sodium hydroxide to neutralize my acid, and then based on my balanced chemical equation, it looks like my acid and my base react in a 2-to-1 ratio. Okay, so what that means is it takes 2 moles of NaOH to react every 1 mole H2SO4. And where did I get those numbers from? I got them from right up here, from the coefficients. So there's a 2 in front of the sodium hydroxide, and then there's no number in front of the H2SO4. When you see no number, that means you've got one of them. Okay, so it's a 1-to-2 ratio. Notice how the units that I start with have to be on the bottom of the fraction. That's how I know that it's 1/2 instead of like 2/1. So the units here need to match the units on the bottom. And then if you plug this in your calculator, 0.015 times 1/2, you get 0.0075 moles of H2SO4. So now I know how many moles of acid were in my original. I want to find molarity. So I go back to this equation again, my molarity equation. Molarity equals moles per liter. And I've got 0.0075 moles sulfuric acid. This is where it's helpful to label my moles, so make sure I use the right number. I want to use the number from B and not the number from A. And I want to divide my moles of sulfuric acid by liters of sulfuric acid. So I'm going to go back up to my problem, and notice in my problem I'm given 2 volumes, 75 mils and 50 mils. So you got to make sure you read through it carefully and choose the right volume. So since I'm trying to find molarity of sulfuric acid, I need to use the volume of sulfuric acid, which is 75. And I need to convert my volume into my milliliters, I should say, into liters. So this is actually 0.075 liters. So my molarity is 0.1 molar. All right, so that's one titration problem. Let's do 2 more just to make sure we've got the hang of it. Okay, here's a different reaction. We've got a different balanced chemical equation. You'll notice in this reaction it appears as if it's a 2-to-3 ratio in which my acid and base react. First step is always going to be use the molarity and volume that you're given to figure out how many moles you added. So in this problem, looks like it took 40 mils of 0.5 molar base to neutralize your acid. So molarity times liters equals moles. My molarity is 0.5. My liters is 0.04. And then we plug that in your calculator, 0.5 times 0.04, you end up with 0.02 moles. I'm going to label it so I make sure I keep track of what's what. So it's moles of calcium hydroxide. So here, my next step, I know moles of calcium hydroxide. So I'm going to use my answer from A. And then I'm trying to find moles of H3PO4. So the unit that I have goes on the bottom. So I'm going to put moles calcium hydroxide on the bottom. The unit that I want should go on the top. That's moles H3PO4. This should hopefully sound familiar from stoichiometry. And then I'm going to look up to my balanced chemical equation to find that mole ratio. So it looks like in this case there's 3 moles calcium hydroxide for every 2 moles of H3PO4. That is phosphoric acid. That's commonly found in sodas. Like if you look at your can of Coke, it's got phosphoric acid in it. Okay, so 0.02 times 2 divided by 3, you end up with 0.013 moles of H3PO4, phosphoric acid. Now let's find molarity. So molarity is moles per liter. By the way, this equation, in case you forget it, it's going to be on your equation sheet on the test. You don't even have to memorize it. You just have to know where to find it and know how to apply it. So I've got 0.013 moles of H3PO4. I gotta make sure I choose the right volume. So I want to use the volume of H3PO4, which is right there, and that is 100 milliliters. Divide by 1,000, that gives me 0.1 liters. So my molarity is 0.13. Okay, let's do one more. Let's look at problem number 14. And again, I've got a balanced chemical equation here. It's the same reaction as above, so I've got a 2 to 3 acid to base ratio here. And first step is going to be use whatever molarity and volume I'm given to find moles. Okay, so I know the molarity and the volume of base, it looks like. So I'm going to take my molarity times liters equals moles. So that's 0.6 molar times 0.08 liters, because remember, take your volume, divide by 1,000. So 0.6 times 0.08 gives me 0.048 moles of calcium hydroxide. Okay, then I've got 0.048 moles calcium hydroxide, and I want to find moles of H3PO4, my phosphoric acid. So the unit that I have goes on the bottom, so moles calcium hydroxide goes on the bottom. What I want on the top, that moles H3PO4, I'm going to look to my chemical equation to find the mole ratio. So it's 2 of these per every 3 of these, according to my balanced chemical equation. And then 0.048 times 2 divided by 3 gives me 0.032 moles of H3PO4. So now I know my moles of acid. I just have to do my last step where I take my moles divided by liters to give me molarity. So I've got 0.032 moles of phosphoric acid. My volume of phosphoric acid is 75 milliliters. Divided by 1,000, get 0.075 liters. And I've got 0.032 divided by 0.075, and that is 0.43 molarity. So there's our some titration problems. Please come by tutorial if you have questions.